Hi folks, how are you doing? Happy Saturday, another beautiful day out there. I've gone ahead and with the isolation and lockdown, I've gone and shaved all my hair off in frustration at how floppy and long it was getting. That's been my response this week to the lockdown. I hope you're all keeping pretty well. Otherwise, I thought this week we'd look at something different, kind of a bit fun. Blender, we all know about the fact that Blender does animations. And we've done a little bit of that, but it also has a very powerful built-in physics system. So why might you want a physics system in Blender? Well, you could want it for making some movies, of course, or you might want it for sometimes maybe the way to set up a scene looking very natural might be to allow things to kind of fall and roll and, you know, just to kind of position themselves using physics in a natural way, and then that would be your kind of finished image that looked naturalistic. So maybe building a wall out of blocks and letting it fall down on its own, which would give you a more natural look than if you tried to place all the fallen blocks, you know, just for example. And of course the third reason is just maybe it's quite good fun. So I thought we'll have a look at that, and let's see what we can see with the Blender physics, something entirely new that we haven't looked at before. So again, just open Blender with the default scene, and I'm going to stick on my screencast keys here again, so hopefully they stay working for the duration of the video. Looks good. Okay, so let's just take the default cube for the moment, and we'll start with that. So what happens if we put some physics on it? So we're going to have to negotiate our way to the physics property tab here, this one here, with a little kind of ring on it. And you can see there's a whole bunch of stuff in here. We're only going to look at a very limited subset of videos of physics, which is the rigid body physics, okay, which is sort of the simplest physics, kind of things that don't deform or squish or flow. So you can see, in contrast, you have soft bodies and fluids and cloth and stuff. Those are things that kind of deform over time as they move. The rigid body, they stay the shape they are, and then they kind of fall and bang into each other. And create interactions that way. So let's just hit rigid body there, and it'll add some rigid body stuff on. So there's only a few things we need to worry about right now. One is the type, which is active. We'll leave it at that for the moment. The mass, we don't want to worry about that too much at the moment. Sometimes if we want to make, so we'll adjust that if we want one thing to seem significantly heavier than the other. We'll see whether we want that or not. Collisions are the kind of shape that it's going to use when it's testing to see if two things have banged together. And convex hull is good for abstract shapes. It's kind of a simple way of wrapping a shape around something that's otherwise complicated. But in this case, actually, we've got a very simple box shape. So actually, convex hull doesn't suit as well as just simple box. So box is quite simple. So we're just going to switch convex hull to box there. Let me see what else is in here. Dynamics. Yeah, I think that's pretty much it. We don't need to worry about the rest of those things at all at the moment. We just forget about them. Alright, so now we've set a rigid body on this, so nothing's happened so far. But of course that's because we're not playing, the animation system is not playing. Let's just go ahead and hit the space bar, or hit the play button there, the forward play button. And immediately what happens is our box under gravity starts to drop away. And it'll do that for the length of the animation. Keep getting further and further and further away. Alright, so far, so not terribly interesting, but that's grand. Alright, so we've got our box, so our box falls. So let's just take our box and let's just move it in Z, maybe a few squares up. Let's go G, Z, 10, maybe let's take it up by 10. Alright. So now let's add in, now the box is kind of up off the ground, let's add a new plane in. So actually a keystroke I use for add is obviously can be found over here, but add is one you do quite a lot. So actually I've learned that Shift A is a quick one for add. It just brings the add menu up. So if you want to try that for add, you can use Shift A. Let's add a plane in there, and I'm just going to hit tab to go into edit mode and just scale it out by 20, and just make a nice big flat ground. And let's hit tab again to come out of edit mode. So now we're back in object mode. So now we've got a cube hovering over a plane. Let's hit the space bar. And disappointingly, the cube just fell like the plane wasn't even there, so let's stop that and rewind the animation. So why did it do that? Well, it did that because, of course, it doesn't see the plane as something that it should consider banging into. So let's go to select the plane instead and go over to the same physics panel again. Let's hit rigid body over there. And just for a second, we'll do the wrong thing and we won't change anything here either. So now let's hit spacebar again. And now, oh dear, the plane and the cube are both falling away. Well, we didn't want that either. So how do we fix that? Well, the plane, we want it to be part of the physics system and we want things to bang off it, but we don't want it to move. So how do we tell the physics engine that basically we just want it to sit there and allow things to bang into it? We do that by changing the type over here from active to passive. So now that it's passive, we hit spacebar again, finally, boom, this time we get the effect we want. It didn't move, but it did interact with the cube. Very satisfying little boom bounce as it fell there. Let's rewind the animation again. The thing that contributed to that bounce is the surface response. So we might take a look at that. Let's click on the cube first and look at surface response. Friction is how much resistance there is to something sliding across the surface. And bounciness is how much of the energy of the impact is given back to the thing. So if you take a bouncy, one of those super bouncy balls and you drop it on the ground, it'll come back a certain amount of the height that it was originally dropped. It won't come back the whole way up, but those bouncy balls are very bouncy, so maybe they'll come back, maybe 80%, and then it'll come down and it'll come back up 80% of that, and so on, getting less and less and less each time as the energy is taken out of the ball as it falls. That's kind of what the bounciness is. A very high bounciness means that something will get a lot of the energy returned back to it, but something less than 100%. So let's just try increasing the bounciness value up to quite a high value, maybe like 0.8 or close to 0.8, doesn't have to be very exact. And let's try dropping it again. And actually we see it didn't really change very much what it did. But the reason for that is that the bounciness is a combination of the two things that are hitting, and the bounciness of now that I've selected the plane here, we look at the bounciness for the plane, it's still 0. So really that's as if one was multiplied by the other to find the total bounciness, and that was very, very low. So let's just increase the bounciness there to a high value again, around 0.8. And now when the cube hits, boing, a lot of that energy is returned back up. And it's like a trampoline all of a sudden. So that's quite good fun. So by controlling the bounciness and the friction, you can control how it behaves. If friction was 0, when something hit the plane and was moving sideways, it would just keep sliding. It wouldn't stop. There was nothing to resist it. And no, the real world's not like that. Ice is about as close as you get in the real world, but in the real world nothing slides forever. So a little bit of friction is always good. You can even tweak these values live actually, and sometimes you can see the interaction. I think in theory, if I was to set the bounciness of both of these to 1, maybe, the friction might be taking account of something, but in theory it really should keep bouncing and not stop bouncing. But I'm not sure that the physics simulation runs out anyway before. You can see the higher those values, the greater it bounces. Okay, so that looks pretty good. So I'm going to stop that animation, rewind again. So again, I'm going to just bring the bounciness back down to a more sensible value. And the same for the plane. Again, quite high, but not like crazy high. Again, something like 0.7 there, that'll do. Yeah. There's no right numbers here, it's just what looks good. What looks good for what you're trying to do. So what I'd like to do actually is I'd like to take this cube and I would like to build a stack of these cubes around, and then maybe we'll drop a big ball down on top of them and see what happens. Just smash the stack of boxes up. So that would look pretty great. So let me just have a look at, let's look in from the side here, and let's just move this box G, and we're just going to move it till it's just resting on the surface, somewhere off to the side, not on the not dead on the center, just maybe close to it but not. And you want it close to the surface, but not. You don't want it crossing through the surface. That's because when they're pushed through each other. Well, let's see if my hunch is right. I've just pushed the cube ever so slightly through the surface there. I think when I start playing that, sometimes you might find it actually flings. It might actually fling the cube away if the two things are cutting through each other. Now it didn't do it there. It actually was okay, but I'm just gonna try and place it so it's close to the surface, but not on it, but not cutting through it. That looks pretty good to me. Not cutting through it. Okay, so, and again, I'm just gonna go for top view, and I'm gonna just move it again, just slightly off to the left hand side like that. Okay, cool. Now, how do I make a few of these boxes? Well, we've got the old array modifier, which can do that for us. So let's go to the array modifier, and we're going to add an array. Now, be careful when we start doing this, because you don't want to make too many objects, because that will really drag your PC to a halt. So we're going to be slightly conservative with how many things we make here. So I'm going to make so relative offset. I'm going to set it just a little bit greater than 1, just to separate them from each other like that. And I'm going to make maybe 4 like that. Okay, 4 like that. 4. So that's 4 in x. 1.1 relative offset in x. I'm going to add a second array modifier, and this second one, I'm going to change that x to 0, and I'm going to change it to 1.1. 1.1 in y instead. And again, I'm going to change the count to 4, so we've got 16 now, 16 little cubes. And then I'm going to add one more array modifier again. And this one instead, I'm going to make it 1.1 in Z. And I'm going to just make 3 layers this time, not too many. So there we go. So we've got still quite a few cubes in there, but not as many as, not too many, hopefully, for your PC, with a bit of luck. So we want to now actually, I wonder if 1.1 is too much for the Z actually. Yeah, now let's bring that last one, that Z, down much closer to 1. We don't want them to have to fall too far to settle on each other. Let me just take a number. 1.01 maybe, just gives a tiny gap between them, but it's not too much. Yeah, 1.01, so they'll settle down on top of each other very quickly. Now, the thing is, when we run the these are all still stuck in one object, which we don't want. We want them all out as separate objects, so we need to do that. So go to the top of, so you've got to start with the first top down. You've got to apply these array modifiers these modifiers in order. You also have to apply modifiers from the top downwards to make it look exact, to keep it the same as it looks there, because that's the way they're applied. So we're going to hit apply on that first one, and then now this is the second one. Apply there again and apply there again. Now they're all gone, and now we've got an object which has all of those separate boxes in it. Okay, but it's still one object, and we want to separate it all out. Before I do this, I'm going to move it to a new layer. So actually, I'm going to hit the M key, empt, and then create a new collection, and I'm just going to call it boxes, because we're going to end up with a lot of little separate objects here, and it's handier to have them all in a separate collection, so we can easily select them. Just keep them separate from the plane. All right, so now let's go into edit mode again. Tab A if it's not A to select all. They already are, and then we're going to separate by loose parts, as they call it. Separate every bit that's not connected to every other bit. I think it's probably, I know the keystroke for, I think it's here, yes. So separate by loose parts. And see what's happened now over here. We've ended up with all of these cubes separated. So that's great. So now each one of these we should be able to select. Let's just do Alt 8, select none. Oh sorry, I'm still in edit mode, tab out. So let's just, yeah, you see each of these cubes now is separated. But one thing you probably have never looked at before, but I call you to notice it now, is that that orange dot is the reference point of the sort of the position, represents the position of each of these cubes, and we would like that reference point, or for each of these cubes, to be in their own centers and not in the center of the first cube. And if we were to put none of these have rigid bodies on them now, I don't think. Or did they? Oh, they do actually. Sorry, they all inherited it from the original. So they all do have rigid bodies on them. But if I play this at the moment, I think we're going to get some weird behavior. Yeah. They just all kind of blow apart from each other. And that's because they're not working properly, because all of their boxes for colliding are all overlapping here around this position. So every single box, the box for its collision is there. It's not around the box that we can see, but they're all here, which is wrong. Luckily, it's super easy to fix that. So let me just right click on the collection here and say select objects. And then for each, we're going to go to object, and then we're just going to set origin to geometry. And it's going to automatically put those centers into each individual box. So if I select one box now, each box, you see that dot is now in the middle, which looks good. And actually, there's a kind of a black outline here, which is the collider. And that's also perfectly wrapped around the boxes. So when I hit play now, the boxes, they settle down right at that first second. They just settle down on top of each other. But they don't just kind of go flying randomly around the place. So that's exactly right, that's what we want. Okay, cool. So let's go back let's select the main collection again, and let's add in, again I'm going to use Shift A, let's add in a nice big UV sphere for ourselves. And let's tab in, I can't even see it at the moment, let's hide the boxes collection just for a second. Let's tab in and let's into edit mode, and let's scale it up in edit mode to be quite nice and big, something like that. Let's come out of edit mode again. Let's G, Z, and just move it up. I don't know how far, good bit. Give it a nice long drop in, and I'm just going to put shade smooth in it as well, because it's just going to look nice. Alright, so let's go to the physics tab for this one and hit rigid body. And this time I think what we will do is we'll give it a bit more mass, and we'll give it a bit of bounciness, maybe not so much. This thing has got like a big steel ball. Alright, let's turn back on our boxes. Okay, it's going to come right down the center of them, so let's see what happens. Wish the boxes look. Alright, so it's cool. It didn't kind of push down through the boxes enough. Not like I really kind of hoped it would kind of smash them. And that's probably because we hit it right on the top, right in the center of the boxes. That's probably the strongest place to hit the boxes. So what we're going to do is, let me go for a top view here, and let me just take the ball and G and just move it so it's more hitting at the side of the pile of boxes like that. That I think will be more satisfying. Alright, let's hit play again and see what we got. Boom. It looks pretty good. So there's no end to the amount of playing you can do with this now. But yeah, you can just have some fun with it. It's going to sort of a short little tutorial today, but there's a lot of scope for play here. There's no reason you couldn't start making ramps and stuff and running balls down ramps and things, and see what you can. You've got enough now to try and create some stuff. So have a go with that, run with it, see if you can come up with some fun things, something more interesting than smashing a pile of boxes, and let me know how you get on with it. Thanks folks, mind yourselves, and hopefully I'll do another video for you all soon. Bye.